Okay, so today I can predict the outcome of future events. So according to the table, how many classes is he considering? Let's see, there are three classes here. We have drawing, martial arts, and dance. So there are 3 classes. And how many days are the classes offered? We can see Monday and Tuesday. There are 2 possible days. So we're going to do something called a tree diagram. And a tree diagram is something that just visualizes all of the possible outcomes. So we're talking about both classes and days, and understanding that drawing on Monday is different than drawing on Tuesday. So we fill out. Our first thing we can look at are the number of classes. Drawing, martial arts, and dance is the 3rd class. Okay, and we know for all of these, they're offered on Monday and Tuesday. So Monday, Tuesday, Monday, Tuesday, Monday, Tuesday. Okay. Now, when we talk about something called the sample space, that is just what the final outcomes can be. So we could have drawing Monday, we could have drawing Tuesday, we could have martial arts Monday. So if we have martial arts Monday, we also have martial arts Tuesday. And I'll do some shorting there, martial arts Tuesday. We could have dance Monday. We could have dance Tuesday. Okay. So when we look at our sample space, we have dance Monday as one option, drawing Tuesday as a second option, martial arts Monday as a third option, martial arts Tuesday as a fourth option, dance Monday as the 5th option, and dance Tuesday as the 6th option. So when we look at number 4, saying find the product of 2 numbers you found in exercise 1 and 2, how does that number compare to the outcomes? How does that number of outcomes compare to the product? Well, let's see. There were 3 options in 1, 2 options in 2. That is going to be 3 times 2, which is 6. How many outcomes did we find in step 3? Again, we found 6 options. It is the same. Okay? So let's go on to the next page. The fundamental counting principle. This is going to be critical for us to learn. Okay? We're going to be using this every day during this unit to determine how many possible outcomes there are. If event M, capital M, has M possibilities, lowercase m, possible outcomes, and event N has N possible outcomes, then event M followed by event N has M times N possible outcomes. So let's go back to our previous example. Okay? Event 1, we're looking at classes. That was the first event, and there are 3 possible outcomes. Event 2, we're looking at days, and there were 2 possible outcomes. What this is saying is that we can use multiplication to figure out the total number of outcomes instead of making a tree diagram every time. We need to be able to make that tree diagram still, but we can use the fundamental counting principle to tell us how many outcomes there are going to be. We're saying that in event 1, in the classes, there are 3 outcomes. In event 2, days, there are 2 outcomes. So the total number of outcomes is going to be 3 times 2. It says you can use multiplication instead of making a tree diagram to find the number of possible outcomes in a sample space. This is called the fundamental counting principle. Okay. Already we've introduced several vocabulary terms. Vocabulary is going to be critical for us during this unit, because there are going to be a lot of different words that have specific meanings. So let's make sure we're understanding those vocabulary terms. Let's take a look at example 1. Find outcomes. Find the total number of outcomes when a coin is tossed and a number cube is rolled. Let's see, flipping a coin is our first event. Rolling a die is our second event. So a coin has 2 possible outcomes and a number cube has 6 possible outcomes. Multiply the possible outcomes of each event. So our first event has 2, our second event has 6. So in total, we have 12 possible outcomes. If we draw a tree diagram, we can see the same thing. 2 options for the coin. We have 6 options for the number cube. So we could have heads 1, 2, 3, 4, 5, and 6. We could have tails 1, 2, 3, 4, 5, and 6. So we can see our total number of possibilities, okay? So find the number of total outcomes when choosing from a bike helmets that comes in 3 colors and 2 styles, okay? So I'll give you a hint. This is event 1 and this is event 2, okay? Go and figure that out. And once you're done, open up your Spiral notebook. Okay, so we have event 1 has 3, event 2 has 2, 3, 2. So we have 6 possible outcomes. 6 possible outcomes. Okay. Sorry, we don't need to go down there quite yet. Like I said, you should be in your Spiral notebook. There we go. Okay, we're gonna get a couple more examples here. Okay. What I want you to do is think about how many shirts you have, how many pants you have, and how many shoes you have. We can use fundamental counting principle when there's more than 2 events as well. So let's say on average, an 8th grader has 40 shirts. 40 shirts, okay? Let's say for pants, they have 20 pants. And for shoes, we'll say 8 pairs of shoes, okay? If we want to figure out how many outfits we can make between 40 shirts, 20 pants, and 8 pairs of shoes, all we would have to do is 40 times 20 times 8, and we would have 6,400 different outfits. Okay. We can do the same thing. You might see something at an ice cream shop. Okay. So let's take a look at an ice cream shop. Let's say we have different flavors. Okay. Let's say we have chocolate, vanilla, we have mint and chip, and we'll go with one more, cookies and cream. Cookies and cream. So those are our flavors of ice cream. Okay. Then we have toppings. Okay. Then we have toppings. We have fudge, we have caramel, we have sprinkles, we have a shell, and one more topping, we'll go with butterscotch. Okay. And finally, we have size. We have small, medium, large, and XL. Okay. If we want to figure out how many possible combinations we could have here, we need to first figure out how many possible outcomes there are for each event. Okay, so we have event 1, 2, and 3. Think about how many outcomes are there for event 1. Of course, there are 4. For event 2, there are 5. And for event 3, 4 again. Okay, so we want to figure out how many possible combinations there are. We would do 4 times 5 times 4. We would end up with 80 combinations. 80 combinations. Okay. If we wanted to make a tree diagram, we absolutely could. Okay. We would start off with all of our flavors: chocolate, vanilla, mint chip, cookies and cream. But then we would have to have 5 toppings for each of those. And we'd have to have 4 sizes for each of those. And all of a sudden you can see how making a tree diagram is not necessarily a great option when we're looking at large number of combinations. Okay, large number of combinations. Anything I would say over 15, a tree diagram is not going to be the most effective use of time, space, and energy. Okay, we're going to add one more page here. Okay. Okay. We're going to take a look at something called like a repeated action. Okay. So something like a locker combination. Okay. For a locker combination, we know that there are 3 possible numbers. 3 numbers. Okay. So on your lockers, you go all the way from 0 to 50. Okay. Actually, I think it's 0 to 49. Okay. 0 to 49. What a lot of students try to do is do 50 times 3, and that is not the option here. Okay. We have 3 events here. We have our first number, our second number, and our third number. Okay. With our first number, we have 50 options. From 0 to 49, that's 50. Okay, 1 through 49 and 0. With our second number, we could still have any of those same 50 numbers. So 50 again. And our third number, we still have 50 options. 50. So it's not 50 times 3. It's 50 times 50 times 50. And this gives us 125,000 combinations, not 150. Okay, 125,000 combinations. All right. We can see a similar process when we're looking at passwords. Okay. Okay, so if we're looking at passwords, let's say for your phone, right? We're going to have 4 numbers. And we have from 0 to 9. 4 numbers from 0 to 9. So our first number, we have 10 options. Our second number, we have 10 options. Our third number, we have 10 options. And our fourth number, we have 10 options. It is not 10 times 4. It is 10 times 10 times 10 times 10. One more there. And this gives us 10,000 combinations. Okay. So I'm going to give you one example to try on your own. You're going to do like a school password. Okay. There are going to be 8 characters. And we're going to just limit it to our 26 letters. Okay. Limit it to our 26 letters. Okay. Take a moment, try to set that up, see if you can figure out your answer. It's going to be very, very big. Even if you can't find the number, at least try to get it set up, and so that way you can see exactly how to find it. Okay, go ahead and pause the video, try to figure that out. All right, we should have had, for our first character, we had 26. Okay, for our second character, we had 26. For our third character, we have 26. For our fourth character, 26, 5th, 26th, 6th, 26th, 7th, 26th, and our 8th character, yes, that's right, we have 26 options. So 26 times 26 times 26 times 26 times 26 times 26 times 26. What we find is that number is very big. That number is 26 to the 8th power. Okay. Which is 2088 27064576. So let's see. That number is 208,827,064,576 combinations. Okay, and that is just 8 characters of 26 letters. When we start adding in numbers, special characters, including capital letters, that size continues to increase dramatically. Okay, that's our lesson today.